Okay, there is, in my book, I have a chapter on quantum consciousness, which is perhaps the most bizarre form of consciousness in all of science. According to the quantum theory, in order for something to exist, somebody has to look at it. Somebody has to make an observation. Before you thing, in principle, it could exist in all possible states. When you look at it, it then assumes one state. Therefore, the observer, in some sense, determines existence. But observation requires consciousness. Conscious people make the observation. So the greatest paradox in all of science is the cat problem, the Schrödinger cat problem. If I have a cat in a box and I don't open the box, the cat could be either dead or alive. So how do we physicists describe a cat that you cannot observe? Well, we add the dead cat to the live cat. We add the two waves together. So the cat is neither dead nor alive until you open the box. Now Einstein thought, this is stupid. I mean, how can you be neither dead nor alive at the same time? Well, what can I say? Einstein was wrong. Electrons can be spin up or spin down. Electrons can be here or there at the same time. So this is the greatest paradox in all of science. How do you resolve the fact that you can have dead cats and live cats simultaneously exist in another state before you make the observation? And if you ever find the solution to this puzzle, tell me first.
I must disagree with my esteemed colleague here. Okay. First of all, let me say that science is the engine of prosperity. From steam power to electricity to the laser to the transistor to the computer.
That's not true.
We're talking about, hey, can I have my okay. Sure. You had your say, let me have my say.
Yes.
However, the information revolution has a weakness, and the weakness is precisely the educational system. The United States has the worst educational system known to science. Our graduates compete regularly at the level of third world countries. So how come the scientific establishment of the United States doesn't collapse? If we're producing a generation of dummies, if the stupid index of America keeps rising every year, just watch network television and reality shows, right? How come the scientific establishment of the United States doesn't collapse? Let me tell you something. Some of you may not know this. America has a secret weapon. That secret weapon is the H-1B. Without the H-1B, the scientific establishment of this country would collapse. Forget about Google. Forget about Silicon Valley. There would be no Silicon Valley without the H-1B. And you know what the H-1B is? It's the genius visa, okay? You realize that in the United States, 50% of all PhD candidates are foreign-born. At my system, one of the biggest in the United States, 100% of the PhD candidates are foreign-born. The United States is a magnet sucking up all the brains of the world, but now the brains are going back.
Right.
They're going back to China. They're going back to India. And people are saying, oh my God, there's a Silicon Valley in India now. Oh my God, there's a Silicon Valley in China. Duh. Where did it come from? It came from the United States. So don't tell me that science isn't the engine of prosperity. You remove the H-1B visa and you collapse the economy. In Wall Street Journal, editorialized against a congressman who wanted to ban the H-1B, saying they'll take jobs away from the American people. The Wall Street Journal said, look, there are no Americans who can take these jobs. These are at the highest level of high technology. They don't take away jobs from Americans. They create entire industries. And so that's why we have an Achilles heel, and that's the educational system. And again, sociology majors are not necessarily going to be the ones determining the future of Silicon Valley, but physicists, engineers. We need more of them, not less.
Making contact with alien civilizations in outer space, how to deflect meteors, what happens when robots become super powerful. These are all subjects that we take in the second season. And, you know, some people ask me, well, why do this? And one thing is that I get to interview the world's top scientists in all these fields. So altogether, I've interviewed about 300 of the world's top scientists. So when I talk to them about the future, it's just not some science fiction writer just BSing about what he thinks the future is going to be. I'm talking to the scientists who are inventing the future in their laboratories. I have a front row seat to be able to get on the telephone, talk to Nobel laureates, directors of the major laboratories, and say, what is your dream? What do you think 2050, 2100 is going to look like? And to me, that's a thrill of a lifetime. Because instead of speculating, instead of moaning and groaning about when we're going to have flying cars, I can talk to the people who are inventing the future.
Let me tell you a cautionary story about a physicist. Over 200 years ago, we had the great French Revolution. And one day, there were three gentlemen about to lose their head to the guillotine. There was a priest, a lawyer, and a theoretical physicist, just like me, about to lose their head to the guillotine. Well, they put the priest's head on the chopping block, and they asked him, do you have any last words before we slice your head off? And he said, yes, yes. He said, God from above shall set me free. Well, all eyes were on the blade. They raised the blade. The blade came down, swish, and stopped right before it hit the neck of the priest. The crowd gasped. They had never seen this before. And so the mob said, let the priest go, because today God has spoken. And now let's see about the lawyer. Yes, the lawyer. They put the lawyer's head on the chopping block, and they asked him, do you have any last words? And he said, yes, maybe the spirit of justice and mercy shall set me free. Well, all eyes were on the blade. They raised the blade. The blade came down, swish, and stopped right before it hit the neck of the lawyer. This time the mob went crazy, dancing in the streets of Paris. People were saying, God has spoken, justice and mercy have spoken today. And now let's see about the physicist. Well, they put the physicist's head on the chopping block, and they asked him, do you have any last words? And he said, yeah, I got some last words. And he said, you know, I don't know too much about God, and I know even less about the law, but I do know one thing. If you look up, you'll see that the rope is stuck on the pulley. And then the physicist said, if you remove the rope, the blade should come down real good. Big mistake. Big mistake. Well, the rope came down, the blade came down, and the poor physicist's head came down. And it just goes to show you, sometimes we physicists have to know when to keep our mouths shut.
Well, detectives say, follow the money. Astronomers say, follow the water. Because where there is liquid water, there could be life. And that's the game changer that took place just last week. This is the holy grail of planet finders. That is, finding an Earth-like planet in the Goldilocks zone. This planet is 20 light years away from the Earth. It's about 120 trillion miles away from us. So a Saturn rocket would take tens of thousands of years to reach that planet. So don't think we're going to find anything soon or visit that planet anytime soon. However, it's part of a 6-planet system, a red dwarf with 6 planets going around it. One of these planets is the Gliese 581G, the planet that was just identified. Size-wise, it's about 20% larger than the Earth, size-wise, but mass-wise is about 3 to 4 times larger than the Earth. But the important thing is that it's smack in the middle of the Goldilocks zone. We hit the jackpot on this one. And remember that we're now going to find hundreds of these Earth-like twins. We have the Kepler and the Kourou satellites in orbit, 2 satellites, one American, one French. They are specifically designed to find hundreds of Earth-like twins in outer space. So one night, when you look at the night sky, you will say, there are Earth-like twins, and you will wonder whether anyone is looking back at us. Now, you ask how we detect them. if a planet goes around the mother star, they actually orbit around a center of gravity like a spinning dumbbell. Now, you remove the planet, because you can't see the planet, and the sun wobbles. So it's the wobbling of the mother star that we look for, because the whole system cannot be observed by telescope. That's how we found this planet in space.
And let's talk about cancer. Believe it or not, we can now attack cancer cell by cell. This is undergoing human trials right now, not monkey trials, not mouse trials, human trials right now, as we take molecules, arm them with poisons, and they seek out individual cancer cells and kill them. One way, for example, is the following. A cancer cell has holes on its walls. The holes are large and irregular. A normal cell has small, round holes. Cancer cells have large, raggedy holes. We can make a molecule halfway between the two, too big to fit in the small hole of a healthy cell, but small enough to fit right into a cancer cell and kill it. That's one of several mechanisms we have of killing cancer cells one by one. And in the next slide, you will see the miracle weapon that will reduce the word tumor and kick it out of the English language. The next device will conquer cancer because of prevention. Watch. It is your toilet. In the future, your toilet will tell you that you eat too much sugar, too much salt in your diet. Isn't the future wonderful? Even your toilet will tell you that you eat too much. But in this toilet, there's a chip. This chip has all the power of Silicon Valley. These chips are so tiny, they capture DNA. That's how small they are. They can capture DNA fragments from cancer cells, identify cancer, and tell you that you will have cancer in 10 years' time. Steve Jobs, the founder of Apple Computer, died of pancreatic cancer. All the doctors say it's aggressive, incurable, unstoppable, kills you in 3 to 4 years. But the genes for pancreatic cancer were sequenced just a few months ago. We found out that that is actually wrong. The cancer which killed the founder of Apple Computer is a slow-growing cancer. 20 years for it to form a tumor which kills you. But only in the last 3 years do you feel it. You don't feel anything for 17 years, but it's growing inside your body. So in some sense, Steve Jobs died too early, because with these DNA chips, we can detect cancer years before it forms. So in the future, your toilet will say, you have cancer. Do something. You have 20 years.
We scientists, Rich, have thought about the possibility that maybe there is a shortest distance, a shortest amount of time. We can divide time into smaller and smaller slices. And so the question is, when you move, are you actually going through many time slices? Or distance, how finely can you slice a distance before you hit the ultimate distance? At the present time, we see no such lattice structure, as we call it, no discrete structure. We have the Large Hadron Collider, which allows us to calculate trillionths of a second, which allows us to measure distances and times that are just astronomically small, unbelievably small, and we see no gradation, we see no choppiness in the structure of space and time. However, once you go to string theory, then there is a possibility that there is the shortest distance. If you take a look at string theory, there's something called the Planck length and the Planck energy. The Planck length is the size of the string itself. It is the smallest object you can create in string theory. So in some sense, maybe there is such a thing as the smallest distance, which is the size of the string itself. The Planck length has also associated with the Planck energy. The Planck energy is the energy of the string itself. If you could somehow access this fabulous energy, which is 10 to the 19 billion electron volts, that's a quadrillion times more powerful than the Large Hadron Collider. At the Planck energy, space and time become unstable. Now this is amazing. You know that when you heat water, eventually it boils. But what happens if you heat space, empty space? According to the theory, if you heat empty space up to the Planck energy, then space and time become unstable. They begin to form bubbles. They begin to form perhaps wormholes, gateways to other universes. Of course, we can't do this with our accelerators, but maybe in the future, an intelligent civilization will be able to harness this fantastic energy and literally become a god, literally create bubbles. These bubbles expand rapidly, and they are the Big Bang itself. So in some sense, you become a midwife to the creation of a new universe. So if it is possible to have the shortest distance, it's also possible to access what is called the Planck energy. And at the Planck energy, these tiny bubbles form, and these bubbles represent gateways to other universes.
Einstein was asked the big question, is there a God? Is there a meaning to everything, right?
Right.
And here's how Einstein answered the question. He said, there really are two kinds of gods. We have to be very scientific. We have to define what you mean by God. If God is the God of intervention, the personal God, the God of prayer, the God that parts the waters, then he had a hard time believing in that. Would God listen to all our prayers for a bicycle for Christmas and smite the Philistines for me, please?
Right.
He didn't think so. However, he believed in the God of order, harmony, beauty, simplicity, and elegance, the God of Spinoza. That's the God that he believed in, because he thought the universe was so gorgeous. It didn't have to be that way. It could have been chaotic. It could have been ugly, messy. But here we have the fact that all the equations of physics can be placed on a simple sheet of paper.
Right.
Einstein's equation is only 1 inch long. And the quantum theory is about a yard long, but you can squeeze it onto a sheet of paper.
Right, with a small enough font. No.
Right? And with string theory, you could even put those two equations together. And string theory can be squeezed into an equation 1 inch long. And that equation, by the way, is my equation. That's string field theory. That's my contribution.
Right.
But we want to know, well, where did that equation come from? You know? This is what Einstein asked. Did God have a choice? Was there any choice in building a universe? When he woke up in the morning, he would say, I'm going to create a universe. I'm going to be God today. What kind of universe would I create? This is how he created much of his theories.
The quantum theory is only controversial when you talk to philosophers, theologians, and the average person. To a physicist, it's accurate to 1 part in 10 billion. We can take an atom, shine a laser beam at it, and I can predict the properties to 1 part in 10 billion. The consequences are the internet, GPS, laser beams, computers, fiber optics, a broadband internet. All of that is a consequence of the quantum theory. Now, you'd think that a theory that powerful would be logical, compelling, and intuitive. Wrong. It is the most bizarre theory ever proposed in the history of science. Einstein couldn't get his head around it. It reduces everything to probability so that there's a probability the electrons can vanish, reappear someplace else. Electrons can be 2 places at the same time and exist in multiple states at the same time. Now, that's stupid. I mean, how can you possibly exist 2 places at the same time? How can you be in multiple states simultaneously? Well, get used to it. That's just the way the atomic world is. So why don't I vanish and reappear someplace else, like on Mars or the moon? There is a probability that I'll do that. In fact, we give our PhD students at our college a question. Calculate the probability that you will vanish and wind up on the planet Mars. Give me a number. It turns out you have to wait longer than the lifetime of the universe for that to happen. But it's a calculable number. This is insane. This is absolutely counterintuitive. But the problem is, it's right. That's how our world is constructed. Our world is stranger than you realize at the atomic level. Now, we don't see it because we average out all these bizarre quantum effects for large objects. We consist of a lot of atoms. But at the atomic level, electrons exist in multiple states all the time. And you know what that's called? That's called the laser beam.
Well, first of all, my daughter is a neurologist, and she handles stroke victims on a daily basis. The first thing you do is when somebody comes in and seems to have the characteristics of a stroke is to do the standard diagnostic test and then run an MRI scan. we can actually see the location of where bleeding is taking place right inside the brain. However, in terms of a cure, we're very far away from that. So I'm very sorry to say that at the present time, the best way to deal with a stroke victim is to immediately put the person in a hospital as soon as they show signs of a stroke, get them an MRI scan, give them the proper drugs, for example, blood clotting drugs, and then at that point we have to cross our fingers. We do not yet have the ability to cure these kinds of illnesses. However, things, for example, like Parkinson's, if you can show that Parkinson's is caused by a cluster of overactive brain cells, we can now put electrodes directly into the brain to neutralize these overexcited neurons, and bingo, the tremors stop immediately. So certain forms of Parkinson's we can actually cure. A certain form of deep depression can be cured in the same way. Again, a cluster of neurons are overactive. By inserting electrodes directly into the brain, we can neutralize those overactive neurons, and the depression is lifted almost immediately. This is not for everyone, but in the laboratory, we've demonstrated the usefulness of what is called deep brain stimulation.
How did the cosmos begin, and how will it end?
Well, we think the universe began with a cosmic explosion 13.7 billion years ago. We know that number to within 1% accuracy, in fact.
How do we know that?
Well, we know the rate at which the universe is expanding. Stars, for example, yellow light from stars is stretched because they're moving away from us, and they turn reddish as a consequence. That's called the Doppler shift. When a car moves toward you, for example, the frequency is high. When a car moves away from you, the frequency is stretched or lowered. It sounds like this. Now, you've heard that all your life. But what is that? That's a Doppler effect. It also works for light beams. When yellow light comes toward you, it's bluish. When yellow light moves away from you, it's reddish. The redder it is, the faster it moves. So it's trivial to calculate the expansion of the universe. You simply look at the night sky and see how much the light is redshifted. Then you run the videotape backwards. We have this enormous, quote, videotape on computer of the expanding universe, so we run it backwards. You've all seen explosions run backwards on television. And then you get back to the point where the universe was a small little dot. That's how we know the universe began, with a fiery explosion. And we can also pick up the afterglow of the Big Bang. When you get a radio and you turn it between stations, you get that static, that zzz static. Believe it or not, a few percent of that static comes from the Big Bang itself. You were actually listening to Genesis on your radio. Your television set, when you have snow on your TV set, a few percent of that snow comes from the creation of the universe. More percent comes from planet Jupiter. Planet Jupiter also causes static on the Earth, which is more than the Big Bang. But we physicists have measured that microwave background radiation. We now have baby pictures of the infant universe. And you know what? It's an explosion. We have baby pictures of the explosion itself. And sure enough, it is a gigantic explosion, just like everyone thought. And we've actually not taken pictures of it in the microwave region. The big question is, how will the universe end? There are two ways it could end, in fire or ice. If it ends in ice, the universe keeps on expanding and gets colder and colder and colder. Or the universe could expand, stop, and then come back and get hotter and hotter and hotter in the big crunch. Either way, the laws of physics say we're doomed. Either we're going to die in fire or die in ice. But there's one way out of this death. The question is, the laws of physics, are they a death warrant for all intelligent life? Most physicists would say yes, that inherent within physics is a death warrant for all intelligent life in the universe, because either the universe dies in ice as it expands or dies in fire as it contracts. I think there's a loophole. The loophole is that billions, trillions of years from now, we'll be so advanced that as the universe dies, we will leave the universe. We will leave our bubble, have a lifeboat, and then go to another neighboring bubble and start all over again. So in other words, this theory of everything may ultimately be the theory of salvation for intelligent life in the universe. Now that's speculation, but in parallel worlds, I even give you the blueprint, the design, how much energy it would take to build a machine which would take us to a neighboring universe.
Do they have control of the situation at the site?
No. It's still a ticking time bomb. Realize that after the big Sumatra tsunami, 90 days after, 3 months after that, there was a huge aftershock. If they have another aftershock, and they're not in cold shutdown yet till next year, the accident could start all over again. It's like hanging by your fingernails. Yeah, it's stable, but you're hanging by your fingernails. In the last 2 weeks, everything we knew about that accident has been turned upside down. We were told 3 partial meltdowns, don't worry about it. Now we know it was 100% core melt in all 3 reactors. Radiation, minimal that was released. Now we know it was comparable to the radiation at Chernobyl. And as far as evacuation, yeah, 12 miles, that's it. You don't have to evacuate beyond 12 miles. Now they find hotspots, 4 hotspots outside the evacuation zone. 34,000 school children now have radiation badges when they go to school.
Kindergartners with radiation badges.
Down to 4 years of age. Can you imagine that? Kindergarten kids with radiation badges going to school. So all the mythology of the accident has been turned upside down because utility has finally fessed up to how severe this accident really was. I'm a physicist, and we tried to reconstruct the accident in our computers given the feeble amount of information they gave us. We knew it was much more severe than they were saying because radiation was coming out left and right. So, in other words, they lied to us. They knew how much radiation was coming out. They knew the danger. They knew how much core melting was taking place, but they tried to put a happy face on it. Well, as you know, workers are being sent in, and they're getting, like a year's dose of radiation just within like 10 minutes at a time. At Chernobyl, 600,000 workers had to be mobilized, each one going in just for a few minutes, each one getting a medal from Gorbachev.
How long will it take to clean this up, in your view?
50 to 100 years.
And we're not there yet. We're not to the point of talking about the cleanup yet because they haven't stopped the reaction. It's still happening.
Cleanup hasn't even started yet. They're not in cold shutdown till next year. Cold shutdown is when boiling stops.
Right.
It's boiling water right there at the reactor, releasing radiation into the environment and releasing radiation into gigantic vats.
How are they storing and disposing of this stuff?
That's the killer, because they have all these vats that are filling up now. They may have to dump it into the ocean again. At that point, the Chinese, the Koreans, the fishermen, they get up all in arms because there's so much damage that every time you put water in, it leaks right out again, highly radioactive, and it's filling up at the site now.
So what do they do with it?
Right now, they're just counting the number of gallons as they pile up, desperately trying to bring more vats in. But once they saturate, they're going to have to dump. And at that point, it's another crisis. It's still minimal around the world. Most of the damage is concentrated within 20 miles, 50 miles of the reactor accidented site. That's where we have the hot spots. That's where we have 20 times normal amount of radiation in schoolyards outside the evacuation zone. But in New York City, you can actually see it in the milk. You can actually see that iodine 131 actually spiked a little bit in our milk in New York City, but it's very small.
Your equation of string field theory and your study into the topic, do you find yourself agreeing with that concept of these multiple universes with many different incarnations, and maybe ours is one of many different types of universes?
You mean to ask me, is Elvis Presley alive in a parallel universe?
Yes.
The answer is maybe. Possibly so. Let me explain. We physicists believe that our universe is like a soap bubble. We live on the skin of the soap bubble. We're like flies trapped on flypaper. We can't get off our soap bubble. But it's expanding. In fact, it's actually accelerating. We can actually see the end. We're all going to die in a big freeze when this gigantic bubble gets bigger and bigger and bigger. Well, we physicists now believe there are other soap bubbles out there. There's no longer a universe. There's no longer a one world. There are many worlds. There are other soap bubbles out there. And these soap bubbles are called membranes, or brains for short. And they can collide. They can peel off, bud other universes. And we're going to test this theory in the coming years.
Yes.
Okay. All science is reproducible and testable. That separates us from religion, which is not reproducible and not testable.
Because so many of my colleagues laugh when they think about intelligent life in outer space. They say, ha, ha, ha. How can they possibly reach the Earth? Stars are so far away. But that assumes that alien life in space is only 100 years ahead of us. Then you're right. You have every right to laugh and snicker, because intelligent beings 100 years from now are not going to be able to go rocketing across the star systems. However, now imagine a civilization 1,000 years ahead of us, 1,000,000 years ahead of us. That's just a blink of an eye with regards to the age of the universe, which is 13.7 billion years. Then new laws of physics begin to open up, new possibilities. So we can't simply laugh at other people's opinions about intelligent life in outer space, because you cannot assume that intelligent life in outer space is only 100 years ahead of us. That's a type 1 civilization. What happens if they're type 3? Galactic, maybe 100,000 years ahead of us. And that's why I think that we scientists have to keep an open mind. And now, of course, we are finding evidence of planets out there in outer space that are just like the Earth. And one day, maybe we'll make contact with one of them.
So let's talk about the brain. First of all, blood flow can be analyzed by MRI scans. On the left is your brain, the blood flow in your brain when you tell the truth. Not much happens. But on the right is when you tell a lie. Ah, yes, when you tell a lie. When you tell a lie, first you have to know the truth. Then you have to create the lie. Then you have to create the cover-up and the consistency with the lie, with all the previous lies you've been telling all these years. That's a lot of brain power. Your brain lights up like a Christmas tree. Now, what have we learned from these brain scans? Well, we learned that the most ancient part of the brain is the back of your brain, the so-called reptilian brain. The brain has evolved from the back to the front. When infants are born, the back of the brain is most developed. That's the reptilian brain. When you have a car accident and you have whiplash, your balance, your sense of territoriality, aggression, simple things like that in the back of the brain are affected. And as the brain grows from infancy into adolescence, the center part of the brain develops. The limbic system, the monkey brain, the brain of emotions, the brain of etiquette, politeness, social norms. That's the center of the brain. And then finally, when you become an adult, the prefrontal cortex at the front of the brain develops. So we can now test old wives' tales by looking at the living brain. One old wives' tale says, every parent knows this, that their teenage kids suffer from brain damage. It's true. You can actually show that as the brain develops from the back to the front, teenagers do not have a well-formed prefrontal cortex. It's another old wives' tale that when a man talks to a pretty girl, he starts to act stupid. It's true. When a man talks to a pretty girl, blood literally drains from the prefrontal cortex, and he becomes mentally retarded. Okay? You can measure this by looking at blood flow. It's absolutely true. Okay? So all these old wives' tales can now be systematically analyzed looking at MRI scans.
In parallel worlds, you discuss time travel. Is it possible?
It could very well be possible. Stephen Hawking has said that, yes, time travel is possible, but not practical. In other words, don't expect an inventor to create a time machine in their basement today. We're talking about the energy of a star, the energy of a black hole. But in principle, if you could master that energy, then you might be able to bend time into a pretzel. The mathematics says so. Even Albert Einstein realized in 1949, his own equations allow you to go backwards in time. If the universe rotated, for example, a very simple kind of universe, a rotating universe, and you go with the flow, you go around the universe as it rotates, you can come back into the past. So simply walking around a circle, you come back not where you left, but you come back yesterday. So even Einstein realized, oh my God, his own equations allow for time travel. So in his memoirs, of course, Einstein had to address the question, is time travel possible? And he said, aha, I have found a loophole. And that is, the universe expands. It doesn't rotate. So it means that if the universe rotated, time travel would become commonplace. So thank goodness the universe expands.
Einstein was asked the big question, is there a God? Is there a meaning to everything, right?
Right.
And here's how Einstein answered the question. He said, there really are two kinds of gods.
We have to be very scientific. We have to define what you mean by God. If God is the God of intervention, the personal God, the God of prayer, the God that parts the waters, then he had a hard time believing in that. Would God listen to all our prayers for a bicycle for Christmas and smite the Philistines for me, please?
Right.
He didn't think so. However, he believed in the God of order, harmony, beauty, simplicity, and elegance, the God of Spinoza. That's the God that he believed in, because he thought the universe was so gorgeous. It didn't have to be that way. It could have been chaotic. It could have been ugly, messy. But here we have the fact that all the equations of physics can be placed on a simple sheet of paper.
Right.
Einstein's equation is only 1 inch long. And the quantum theory is about a yard long, but you can squeeze it onto a sheet of paper.
Right, with a small enough font. No.
Right. And with string theory, you could even put those two equations together. And string theory can be squeezed into an equation 1 inch long. And that equation, by the way, is my equation. That's string field theory. That's my contribution.
Right.
But we want to know, well, where did that equation come from? You know? This is what Einstein asked. Did God have a choice? Was there any choice in building a universe? When he woke up in the morning, he would say, I'm going to create a universe. I'm going to be God today. What kind of universe would I create? This is how he created much of his theories. We physicists today can teleport particles of light called photons. The world's record is 100 miles. From one Canary Island, we can zap a photon and it materializes on another Canary Island. We're going to do that next for the space shuttle. We're asking NASA for permission to set up in the space shuttle a device where we can teleport photons into space and back. And after 2020, when we go to the moon, we're going to teleport to the moon. There's no limit to how far we can teleport.
Wow.
And within 10 years, we'll teleport the first molecule, like water, for example. We can teleport beryllium. We can teleport atoms of cesium. Next will be a molecule like water. After that, DNA. We may be able to teleport a virus. We may be able to teleport life forms. Now, Captain Kirk is more of a problem. Captain Kirk consists of 50 trillion cells. That's how many cells we have in the body. That will require centuries of work. But hey, Star Trek takes place in the 23rd century. That gives us enough time.
That's about right.
Now, the progression of time can play tricks on you. For example, I host specials for BBC television sometime, and we all have the illusion that in a car accident, time slows down. So we did an experiment. We got this guy, gave him a stopwatch and a camera, and we pushed him backwards off a tower. Now, if you're pushed backwards off a tower, you go screaming because you think you're going to die. Well, we had him look at images flashed at him. These images flashed so fast that the ordinary eye can't see it, like a number flashed at him. When we pushed him backwards, he saw the number because time slowed down as you're falling backwards. So you can actually measure this effect, measure the effect that the progression of time slows down when you are, when you're frightened, when you're in a panic mode, the progression of time does change. That doesn't mean that time has changed. It just means that your neural circuits speed up, so you process information faster. You can see numbers which flash across the screen, which normally are too fleeting to be seen.
The Bush administration has long said that it's just a theory that carbon dioxide levels and temperatures fluctuate in synchronization. We now have the proof. We have the smoking gun. It turns out if you go to Greenland, the ice sheet over Greenland has been stable for several 100,000 years. The ice has trapped molecules of air of hundreds of thousands of years ago. We physicists have gone to Greenland and taken ice cores, drilled hundreds of feet right into the ice sheet to capture the atmosphere of 160,000 years ago. We now know what the atmosphere looked like 160,000 years ago, right on the planet Earth. We plotted carbon dioxide levels and temperatures, and we see an exact synchronization. In fact, I even brought the chart with me. And if you look at the chart, you'll see that carbon dioxide levels rise and fall along with temperatures. This is the smoking gun. This is the thing that George Bush said, it doesn't exist, it's a theory, it's a myth. Why worry about the greenhouse effect? In fact, there was a cartoon I saw of George Bush. He was in the desert with no water, and the sun was baking down on George Bush, and he was crawling for any kind of aid. And as George Bush was crawling in the desert, he said, more study, more study.
Yeah,
we
right.
must have more study.
Yeah.
I think we've had enough study. It shows, first of all, the ice cores give us the smoking gun. Carbon dioxide levels are directly related now to temperature changes. And carbon dioxide levels are now the highest they have been in 100,000 years.